And here I am. Okay. So, good morning, good afternoon, good night, depending on where you are joining from. So this is the 18th webinar of the Technical Talks of CTSoc series. I'm Fabrizio Lamberti. I'm the VP of Technical Activities of CTSoc. And I will just give a brief introduction of what technical activities and technical committees are, from where this series of webinars stem from. So the technical activities is one of the areas of consumer technology society. It's one of the areas together with publications, conferences, industry and standards education. So this technical activities areas was created to support the other areas, and it builds on a future directions committee and a set of technical committees. So far, we have 15 technical committees, which, as you can see, are covering broadly the various topics and areas of interest of consumer technology society. This is the overall organization, and you see that there is this future action committee. There are these 15 technical committees, and the officers of these committees, plus the VP of technical activities, so myself, the vice chair of the TC board, Dr. Dixon Lean, the president of CTSoc, Fabrice Labeau, the VP conferences, Fauzi Beman, VP publication, Norbert Ehringser, and the VP industry and standard activities are sitting in a technical committees board, which is governing the activities in this area. I mentioned it, the technical committees, and here you have the titles of the 15 technical committees and the names of the chair, vice chair, and secretary for the 2025-2026 term. Each technical committee has its own website, where the mission and objective, the name of the officers, and the name of the members are reported. And at the present time, you don't need to be an IEEE member to be a member of one of the technical committees. That is very interesting because you can get acquainted and you can start doing things within cities like we didn't actually being a member of IEEE and IEEE Consumer Technology Society. Of course, we hope that at a certain time you will decide to join because of the opportunities that we offer. Anyway, if you want to, if you're not a member yet and you want to join one of the technical committees, there is an application form. Here you have a link and you have also QR code to join. So far, we have approximately 1,500, so 1,500 members, which are spread across the various areas. And this number is growing because we are advertising this possibility. Why is important being a member of the technical committees? Because these technical committees are meant as the engine of the society. They are supposed to support the various CTSoc activities in the various areas like conferences, publications, standard education, and history. And so here you can read what are the goals and objectives of the technical committees. But to be very concrete, over the last 2-3 years, we offered a number of opportunities to the members of the technical committees who have been selected as members in the technical positions of CTSoc conferences. They have been selected as associate editors. They proposed special sessions in journal. They proposed workshops and sessions in conferences. They have been involved in parallel activities which are putting together different societies and councils and OUs of IEEE. They started collaboration with other society also outside IEEE. They created a special interest group. They were selected as distinguished lectures. They are participating as speakers in these webinars. We have been funded projects like student internships, and this is just an example of one of the applications that have been created with this funded projects. They are involved in implementation of standards and so far and so forth. So um, let me mention just some of the opportunities that are currently open. We have some conferences running. One of these conferences has just been established, which is the Fifth International Conference on Intelligent Reality. So there will be chances for members of the technical committees to help, but also in the other conferences that are published in this slide. And also regarding journal, for instance, so the call for associate editors for the consumer electronic magazine and the transactions on consumer electronics just closed, but there are other opportunities like proposing special issues or contributing to the special issues that are currently open. So I hope that I presented you opportunities for being a member of the technical committees of CTSoc. One on the last and the last of, but not the less important of the opportunities is being a speaker in one of our technical talks. So we are at the 18th edition of these webinars. The last webinar is being held in November. This webinar will see the participation of two speakers which belong to the CEA and the IoT technical committees. Well, the first speaker is Dr. Najineni Sukumar. Is, as I said, has joined the TC on automotive CE applications. He is from Active Technical Center, India. And the second speaker is Mr. Muhammad Haris Hassan from the TC on Internet of Things, Internet of Everywhere, and Edge Computing from Stanford University Coding Place, Senior Leader Mentor, USA. So I could leave the floor now to the officers of the CEA and IoTTC to introduce their speakers. So I've seen that we have some of them, like Yogesh, but anyway, I can do that. Yogesh, do you want to step in and introduce the speaker, or do you want me to do that?
You can go ahead, Fabrizio.
Thank
Thanks.
you anyway for having helped with the organization. So the first speaker is Dr. Najineni Sukumar, is an algorithm system software engineer specializing in image signal processor tuning at the Active Technical Center, India. He received his PhD in signal image processing from the Indian Institute of Technology, Roorkee, in 2025. He has authored and co-authored numerous peer-reviewed journal and conference papers in the areas of image and signal processing, computer vision, and embedded artificial intelligence. Dr. Sukumar's work bridges academic research and industrial innovation with contributions to advanced driver assistance system, ADAS, intelligent sensing platform, and next-generation automotive imaging technologies. His research interests include smart image enhancement, real-time vision algorithms, and edge-based AI architectures for automotive and emerging intelligence systems. Today is providing us a speech on smart image signal processing for emerging applications. So thank you for being with us today. The floor is yours.
Um, Thank you, Fabrizio. Let me share my screen. Hope you can see my screen, right?
Yeah, perfect.
Yeah, thank you. Yeah, so this is Sukumar Nagneni. So today I'm going to give a general overview about smart image signal processing for the emerging applications. So the main idea of this talk is to give the general aspect of the image signal processing applications. So let's start with applications. start with the mobile application. So in nowadays in mobile, we are majorly looking for the camera. So the evaluation of the camera, the smartness of the camera is evaluated in so much way. Like, so this is where that the camera is having the image signal processing features. And in automotive applications like a forward view camera and surround view camera applications, so those are important for the ADAS feature development and surround and the surveillance cameras, and also for the action cameras. And also coming to the glasses, like we have the smart glasses there. This camera's role is most important. And coming to the drones and also the robos nowadays, people are using for the warehouse. So warehouse purpose, and even the conference devices like for IoT cameras. So the applications of the image signal processing. So basically, the image signal processing is like a pre-processing technique. So that is where you can improve the image quality. So before getting into any kind of a computer vision features or models. So that's why this is the most important, and also it has a wide range of applications. And let's start with the image sensor. Why we have to start with the image sensor is like in camera we have the image sensor and the lens. So suppose when there is a light, and the light reflectance from the any subject which pass through the lens, and it is collected by the image sensor basically. So the image sensor, what it will do, it will collect the photons, and it will convert to the electrons. And so the image sensor where that the light will be, whatever the reflectance of the light from the any subject from the scene will be converted to the image. Okay, on top of that we will apply the image signal processing. So this is where the role of the image signal processing is coming into the picture. So this is where that image signal processing. And if you look at that, how the image sensor works. So basically, if you look at the image sensor, it's like a combination of the lens and the image sensor and the ISP. So these three are the combinations. And the image sensor. So coming to the image sensor, how it works. So first the light passes through the lens, and then it falls onto then it is filtered to the Bayer filter, and then it reaches to the image sensor. So now we need to see. So the light is like the photons are filtered through the Bayer filter. So first we have to see what is Bayer filter. Bayer filter here. So Bayer filter system is there in our camera. So that is where that whatever the light falls, it is going to be filtered by the different combination of the Bayer sequences. Suppose if I use the R, G, GB, these are my filters. So it means like I have the blue filter, which will pass only the blue color component only, and the red color and the green color. So finally, so this is where my Bayer sequence will be formed. So once this is in unlocked domain, so once Bayer sequence is formed, and it will be passed to the image sensor. So this is where the image sensor is there. So in image sensor, what is happening here? Once image sensor, what is the photons are converted to electrons and voltages and the digital values from the unlocked digital conversion. So once the digital values means like a pixels. So each element in an image is called as a pixel. Once the pixels are available, that is where the ISP is applied. So in the cameras also we have the pre-ISP is applied. So even if you have the pre-ISP is like a only very low level image quality improvement in the camera side. So now what we have to do, we have to improve the image quality. So how we are going to improve the image quality? So let's see, like now we have the lens plus image sensor, and the pre-ISP is available. And next, once that image data is available, this entire thing is the camera. So this entire thing is the camera. Once image data is available, is like a raw image. It's like a raw image. Once raw image is available, next we have to apply the ISP, like image signal processing techniques, to improve the image quality. So now this is the camera is a hardware module. Now we have to process that raw data to the some kind of embedded board, like a controller. Is kind of a controller or the processor. So processor. So how we have to decide the interface. Okay, so now we have seen like the Bayer sequences, and we get the Bayer images. So this is where the Bayer image is there. It will be formed. The form is the size will be like width into height, and the output we can get it in like a, so output, this is raw is there. So once if we process through ISP, then we get the YUV format or the RGB format actually. So we later we discuss about why we have to decide for the YUV formats. So this is the raw image format, and this is the output, the processed image format. And so this is basically a paper. This is a paper from the Omnivision Technologies. They are the one of the leading camera suppliers. So we can go through for a like a 1 minute to this discussion. So you can see on the x-axis is the wavelength, and the y-axis is sensitivity is there. Sensitivity is available. If you look at the R and G and B, so in the visible spectrum, so the R, you can see the dominance of the wavelength of the R is at the higher end, and the dominance for the blue is at the lower end. And if you look at the green is covering the both lower end and higher end. It means like, so our eyes are more sensitive to sensitive to get the green component from the nature or any scene. Okay, so if you have the RGB Bayer filters, if you have the RGB Bayer filters are already available. If you have the RGB Bayer filters are available, but this Bayer filters are making the problem while while distinguishing the yellow light and red light. So basically in the traffic, this is the yellow light. You can see this is not if you capture with RGB, it is not getting yellow light properly. It's not capturing yellow light information. Even red signal also it is not capturing as a red. Okay, so this is the problem with this RGB color filters. So the proposal is to use some kind of a RCCG, is like clear channel. It will pass all the whatever the color component is there. It will pass, and it will collect it with image sensor. So you can see this is the one RCCG. This is where you can see the distinguish between the red, yellow, and the blue. So the color, so so basically there is, so if you use this kind of a filters like RCCG or RYY filters, if you use, we can able to distinguish the yellow light and the red light at the traffic signals. So that is why the combination of the lens and the image sensor, the combination of the lens and image sensor and the ISP is the foremost important to improve the image quality. So it's not like only if we apply some kind of image signal processing on the top of the raw images, we cannot improve the image quality, because it's a combination of the lens. Lens selection is also most important. Okay, so now I am discussing about the interface. Now data is available. I want to send to some SOC or some FPGA or some FPGA board. So I need to send raw data to SOC. So there should be interface is required. So there should be an interface is required. So this is where the camera serial interface is there. So this is like a MIPI camera serial interface. So this is where the camera data is transfers in the serial format. So if we go deep into this one, so every frame there is a V synchronization, like synchronization is like starting of the frame is available, and each pixel you can see is like a bytes actually. So basically, suppose 1 pixel is equal 3 bytes, means like a, you can see each one is like a 1 byte, 1 byte, 1 byte. It means like a 3 bytes RGB. So this is just to get into the overview. So now the image sensor is available. This is our image sensor. Once image sensor data is available, image sensor data is collected. This is where the raw data is available. Raw data, and now it's supposed to be connected to the. So now we have to be apply some image signal processing at our SOC or FPGA side. This is where ISP will be there. So now we will discuss more about the ISP. So we do have the pre-ISP is available in the image sensor, but it's a limited only. So this is the one application like a surround view camera application. You can see there are like 4 cameras are connected. You can see on the right, left, right, front, left, and the rear cameras are there. You can see the areas. The area is covered by. This is the area covered by this one. You can see it like this. So you can see the areas are covered by this image sensor. 4 image sensors are there. So if we don't improve the image quality properly, we can't get the surround view things properly. So once this is the area is now final. This is the area union area, and then Then on the infotainment side, our display side, it will be wrapped to the display in the, you can see in this format. The graphics will be rendering will be happen like this. So what I'm trying to emphasize is like the importance of the image quality improvement. The surround view camera system is most important. So this is a general ISP building blocks. General ISP building blocks. You can see this is the raw bare data is coming from the image sensor. Once image sensor raw bare data is available, we have to look for the what are the dead pixels are. Dead pixels is like the pixel values which are less than their average values. We have to do the dead pixel correction, and next is a black level correction is like there should be some offset value we have to subtract from the each pixel in the image. And next part is anti-aliasing filter. This is where we have whether it is following the Nyquist rate or not. That part here we have to check it. And then the white balancing. White balancing is the most important thing. So the because the gray object looks like gray only, white object the gray object looks like gray only. It should not look like a white. So we can look into the white balancing is the most important thing. And then this is the color noise filtering, and this is where once this raw images will be converted to the RGB image here, then the color enhancement will happen here. And this is where the contrast will be stretching will happen. Contrast stretching will be happen. And again the noise filtering is there, and the tone mapping is a contrast enhancement, and the sharpening details will be. Finally, to reach the RGB data, from the raw data to RGB data, you have to go through the each and every block. This is general ISP pipeline. It can be vary from the supplier to supplier. Like we have the Qualcomm SoC, Qualcomm ISP is there, and the Texas Instruments ISP is there, Umbrella ISP is there, NXP is there. So these image signal processing blocks will be interchanged, but the overall, like what we are trying to improve is like a first thing we are trying to improve the color contrast. So these are the basic things. The color and the contrast enhancement is required, and the sharpness is required, and also noise. We have to reduce the noise. So all these things we have to do it, get the better quality of the image. So this is the same. This is the generalized pipeline only. This here you can get the better view. This is coming from our raw data, bare data. Once this is in the raw domain, this is a suppose in 8-bit image. So basically, if you have the 8-bit image, means like we have the gray levels from 0 to 255. So 0 to 2 power 8 minus 1 is like 0 to 255 levels will be there. So those many gray levels will be presented in the image. Okay, so the operations you can see on the gray color, you can see this is like a raw image. The operations will be applied. Once it will be here, the image size is like height into width with a 8-bit. So once it is converted to RGB domain, you can see here that 8-bit into 3 times of a height into width. Okay, so next RGB we will convert to the YUV, because we have to apply the sharpness on only the Luma component, Luma component, not on the color component. So we'll convert to the YUV, and we'll apply some noise reduction techniques here. And you can see here these are 3 stats. These are most important things. This is auto exposure. So they basically this is going to we have to control the camera exposure time. So this is like open loop system now. So if we have to establish the closed loop, that is where the analog gain, digital gain of the camera will coming to the picture, and the auto white balance also coming to the picture. These are the general ISP blocks. And here what I'm trying to this is like a color wheel. You can see here. Suppose these are, you can see on the last circle, you can see on the surrounded circle, this is the colors. So color. So these are the green color. These are all primary and secondary colors. You can see here. These are like colors actually. So these colors supposed to be appear like colors only. But suppose we have the white. When you add the white with the color, so you can see it will form as a tint. And when you add the color, with the gray, any gray object will be added, then it will be, you can see as a tone. And when you add the color, any color with the black color, you will get this kind of shades. So you will not get a pure color. You will encounter this kind of tints and tones, and the shades are there. So we have to remove these things. Like here, here we, to getting the pure color, we have to remove the white component. So to get the tones, we need to remove the gray component. To get the hue, we need to remove the black component. So basically, this auto white balance is the most important feature. It is already available in, it is available like in all the cameras, wherever you have the cameras, all the cameras it will available. And basically, what is auto white balance? So it's basically the removing the unrealistic color, actually color cast. So the object which appears the white in person are rendered white in your photo. Suppose we have the white objects in our scene, it has supposed to be appear like a white. It should not be appear like a blue. You can see this is in auto mode. This is the perfect color. When you have the color light, so because here color light source, we have the light source are measured with the color temperature basically. So this color temperature looks like the blue color, and you can see the gray color, different colors are, it looks like. So we have to get into the auto color. Okay, so you can see on the left side is the pass criteria. Pass criteria, why we have to say pass criteria is like, you can see the headlamps and street lamps are appear like a proper color. Okay, red color only. But if you look at the right side, you can see the bluish and the pinkish tint is there. So this is where the white balance, we have to remove the white balance from the image. And you can see this image, and here you can see all the street lamps and the headlamps are mixed lighting. You can see here all the lightings are proper only. Okay, with a better quality image. On the right side, you can see again the pinkish and the bluish and the blooming of the light source is also there. So first of all, we get the better quality of image so that we can send to our computers and features. Okay, so that's why image signal processing is most important. And the next thing is the contrast enhancement. So why the contrast enhancement is required? You can see the first image is like you can see the more dark tones are there. Dark tones are there. Okay, when you add the color with the black color, you get this kind of dark tones. Okay, you can see here the more overexposed image is there. Overexposed image region is there. Okay, so this is also the false, this is also fail case, this is also fail case. And here you can see the shade under the tunnel is there, bridge is there. This has to be improved. And you can see on the left, this also be, you can see that the dynamic range is like a differentiation between the high and the low contrast actually. So here also it's not proper. This is okay, the contrast. Okay, so first of all, we have to improve the image quality and image with a different exposure. Suppose if you want to do the high dynamic range, okay, so we have to capture the image with the different exposure time with the low exposure. This is with the time of like 2 milliseconds, 3 milliseconds, 4 milliseconds, 5 milliseconds, and we have to stitch everything. Then we get the blended image with a better fusion image. So next thing is like there's a chromatic aberration correction. So this is our lens is there. This is the lens property, because we have the R and G and B color component is available with the different wavelengths are there. So when the light falls onto the lens because of some because of the optical property, so these three colors are not converged to the single point. So this is where we have to correct this displacement from one reference point. From this reference point, we have to correct this displacement. We have this two displacement we have to correct. That is called lateral chromatic displacement correction. So what does it mean? Like if you don't correct it, what will happen? We can see some kind of a color fringing across the edges of the objects. We can see the color fringing. You can see the left side. So and here also on the left side bottom, you can see this kind of colors will be appear across the edges actually. This is where the displacement, we have to correct the displacement correction. And also you can see and inside the office also on the lights, you can see this kind of pinkish and greenish, because when these colors will converge, it appears like a neutral color. And this is lens shading correction. Why lens shading correction is required means like basically this is our camera lens. This is a camera lens. Camera lens is looks like a circle only, but our image sensor, camera lens is like a circle, but image sensor is a rectangle, like a square format. So the light is not following in these regions. So in this region means like these regions are more darker than the center. So that is where we need to correct the shading from in the radial direction from the center to the corner. We have to radial direction we have to correct, so that the image, the brightness will be appear as a uniformity. So noise reduction is like we have so generally in images we have the noise like we have the noises presented, so we have to apply some kind of a spatial filters. Actually, this is like a 2D spatial filters, like a Gaussian filter. We can apply average filter, average filter. So bilateral filter as well. Bilateral filter we have to apply in the RGB domain. So what I'm trying to mention, like a so noise reduction we have to do. So as of now, what we are trying to do, noise reduction and lens shading correction and chromatic aberration correction. So these all are most important to get a one single RGB image. So finally, we have to improve the sharpness. So for that, we have to apply sharpening filters. We have to apply. It's like a in images, basically high pass filters, like a high frequency component is present in the images. Those are like edges. So we need to extract those edge components, and those edge components we have to extract, and we need to measure that MTF the overall system, to whether we get a sharpness details present in the image or not, because sharpness details will be useful for the computer vision feature extraction. So now we need to, so whatever the, now we have the colors are there. So now the colors are coming properly or not. So now this we have the colors. So now these colors are there. So this color is coming properly or not. This color is coming properly or not. Suppose how we are going to test. So what we will do basically, so these are like a this is like a indoor image called a testing actually in optics lab. So we will capture this reference images and verify. Same image will captured and we'll verify that colors are coming properly or not. This is for the color accuracy measurement. This is for the white balance. White balance is like a starting from the white to the gray. The object looks like a gray object only. Okay, so likewise, so these are the like a optics lab basically from the IMA test and the image engineering and with the IMA with the GUI from the MATLAB. So these are like, this is for the color measurement, color accuracy is coming properly or not, white balance is correct or not, and noise is in the range or not, and also sharpness is details are proper or not, and also spill coin test. So these are like a image quality evaluation and verification, and subjective image quality verification will be done on the real time. So it depends on the specific lighting conditions, and the specific edge cases and test cases will be considered for this image subjective image quality verification. So image quality verification, it will be like under day conditions, night conditions, and under the different luminance lux levels, and different edge cases are considered here. So this is one interesting application like in medical endoscopic image. So you can see here so one of the work is from the 10x engineers. So there they want to differentiate the vessels. This is basically from the medical endoscope image, vessels from the mucosa in the endoscopic images. So you can see on the top image, on the right side top image. So what are the challenges are there? What are the challenges? You can see there is a more the red channel dominance is there on the top. And the first one here, red channel dominance is there in the right side top image, and also the tone contrast is less.
Dr.
So
Sukumar,
there is
just want to
yeah
let you know that we should now move. Maybe it's better if possible if you can move to the conclusion. If you
conclusion.
that would be
So
great.
this is before and after, and this is my last slide. So what I'm trying to say is like a, so this is for only the automotive application, so the ISP is most important. So when we have the camera with the ISP to get the better image quality, so where we are going to use the camera basically in the applications, wherever we have the surround views are there, surround view we have to surround view cameras are most important, and the lane keeping assistance systems and the traffic light recognitions. Okay, so these are the most important to get the better image quality images. Yeah, thank you.
Thank you, Dr. Sukumar, and sorry for having interrupted you because I've seen that you were changing the topic, so I thought you might be moving to something different. I'm personally working exactly on this topic, so I was really inspired by your talk. Um, well, since first of all, let me thank you once again for your talk. Since the time is running out, I would maybe first leave the floor to our second speaker, who is Dr. Muhammad Aris Hassan, Stanford University Coding Place, Section Leader Mentor, USA. I have seen that. First, I want to thank as well Dr. Hassan because I think it might be quite early for him. So thanks for joining. And I would like to introduce him. So, Dr. Hassan is from the TC on Internet of Things, Internet of Everywhere, and Edge Computing. He is currently pursuing a bachelor degree in computer science at Government College University, Faisalabad, Pakistan. He is also section leader mentor in the Coding Place program at Stanford University, USA. His expertise includes designing and deploying end-to-end IoT dashboard using modern web technologies, particularly the MERN stack, MongoDB, Express.js, React, and Node.js. Through both academic mentoring and practical development experience, he focuses on bridging IoT data pipelines with scalable user-centric web platform for real-world applications. He is actively participating in international hackathons and coding competition, contributes to the developer community as a volunteer moderator, and has solved over 200 algorithmic programs on lead code. Is actively involved in Internet of Things IoT technical committee with strong interest in full stack development, IoT data visualization, and edge-enabled web applications. Today is gonna provide a speech on creating full stack dashboard for IoT data, a developer's approach using the MERN stack. So, Mr. Hassan, the floor is yours. Can you hear us?
Hi, can you hear me?
Yeah, sure. Very well.
Okay, nice. So let me share my screen first.
Yeah, that would be great.
Wait. Yes, can you see it?
It's coming. Yeah, here it is.
Okay, so okay, nice.
When you want, the floor is yours.
Yes, just wanted to present it
Um,
on full screen.
yeah, we see it full screen now.
Okay, so and this thing as well. Okay, so first of all, thank you so much for inviting me here, and thank you so much for you, and for me. For now, our topic is creating full stack dashboard for IoT data. So this is our topic, and we will solve this problem using MERN stack, right? So let's go forward. Here is something a bit about me. First of all, I should know it. Okay, so my name is Muhammad Haris Hassan, and I am software engineer, a full stack developer in MERN, specialized in MERN, and also a technical community member, as you said already. Also, I have served in Stanford University as a section leader mentor, and I have participated in many hackathons, like 40 plus hackathons, and I have won two international hackathons. And yes, so let's go forward. So why IoT dashboard matters and why we need IoT dashboards. So first of all, the IoT data is the raw data that we cannot visualize, or simply we can't understand it without we visualize that. After visualizing that data, we can easily understand what is happening in it. So the main thing is converting that raw data into something that show us the real value of the data. Like we will convert that into a dashboard in charts, etc., to uh, for better visualization, basically. Okay, so in IoT dashboard is we will probably we talk about websites, means mostly dashboards are we can see dashboards on web, right? So we can display real time or historical data from IoT. Real time means the data that is currently happening. Like if we uh, talk about temperature or humidity, the thing we can understand is what is the temperature right now and what was the temperature yesterday or day before that. So this is what is mean by real time or historical data. Okay, so we can show charts, tables, and alerts, etc. if temperature is higher than normal, like 35, yeah, 30, or 30, 37, then it will give us alerts or it will show us table and charts of the data. And also it allows us to monitor or analyze the data as well, right? So, and yes, why we are using MERN stack? Basically in MERN stack, uh, can I annotate? Yes. So in MERN stack, the M is MongoDB, E is Express.js, R is Node.js, and R is React.js, and N is Node.js. So it collectively have the full stack that can grip everything very easily. And it is the most popular framework of JavaScript, right? For front end, we need front end because we have to see the UI, the user interface. So for UI, we will use React.js, right? And it is the main purpose here is mentioned is user interface, dashboard, or charts, etc. Like if we see the data like in this form, that is very non-understandable. But if the data is like in the form of charts, that we can see the fluctuation, means in that year it was uh, like here, for now it is here, like etc. So it can be more good in visualization, so that we will use charts. And for backend, because we have to handle the functionality of it as well, so for backend we will use Express.js, and Node.js is for the environment of uh, server. Server means backend, right? So we will handle in APIs and business logic and another functionalities, etc. And for database is to store the data. Like if we have images or text, etc., or the JSON data, that we will store the like here mentioned, stored sensor data and device information, like on IoT, right? So the platform we use is MongoDB, and for its platform, we will use MongoDB Atlas, right? And for the again for the runtime, we will use Node.js, that is server environment basically. So this is the thing. That is why we will use MERN stack, because it can handle everything very easily for us. Okay, so I have to remove it. Okay, so let me remove the. Okay, so here is high level system architecture. Like in our system, we have to handle the architecture that we are following, like uh, how that work will be happening from IoT device to dashboard in the front end. That is our main goal. So for IoT device, we will get data through internet, and then we will create a server, and we will have the backend API that help us to maintain the server functionality, etc. And then we will store the data that will that we will get from API to databases, and then we will show the data on dashboard from databases, and that will our front end. So this is how IoT devices to dashboard workflow will be happen. So in this workflow, the thing IoT device, what we can do with that, we can collect sensor data, because sensor data is the raw data, right? So we will get data and then send data through different platforms like HTTP, MQTT, WebSockets, but mainly we use in the beginning we use HTTP platform. Okay, And then, oh, sorry. And then we will send data to backend. That is in backend is our server that is in Express.js, and it will receive the data and then validate the data. Is there any issues in the data that we should resolve, or that can be restriction in the processing? So we have to validate these things, and then we store the data in MongoDB. For storing in MongoDB, we will send the data to the database that is MongoDB. Basically, MongoDB is collection-based uh, database that is more similar to JSON. So we will store JSON data in the MongoDB, and that will also store real series sensor reading that can help us easy in store device metadata as well. So it can help us a lot because it is more similar to JSON. Okay, then we will simply show our data to our front end, and uh, for showing data to front end, we have to fetch data from APIs to display on our front end, and that will be in the form of charts, table, and alerts, as I told before. Okay, so how device send data means we know we will send data to we will get data from devices and send it forward. So now how we can send the data? So for as I told above before, we will use HTTP REST APIs, HTTP request, etc. There are other methods as well, but the simple and beginner friendly is HTTP. So how the data is looks like? So this is the JSON data. Basically, this is the curly braces that shows its format. Uh, with that curly braces, we can easily understand this is the JSON data. And also collection is in MongoDB, that the way data is stored is in the collection based. That is similar to this. Like if I paste it here and just remove the inverted commas here from here and here. And in the MongoDB, we do not know what data we will get, but we know what type of data we will get. Here, the keys will be same, but the data can be different, but it is in the form of string. So we will just add here string, and in MongoDB, the data is stored in this way. And when like it already know, it will get device ID in the form of string. So it will just match device ID, and then it just allow string to enter here. And this is how data will be stored. Uh, this is what type of data will be stored. So this is JSON data. Like this is key and this is value, key and value. Okay. And for this, it will add number. For this, it added string. And for this is default one. It added in everyone. And for that, it will give the data type like date, right? So this is the kind of data that will be stored there. And for the backend Node.js backend part in Express with Node.js runtime, its responsibilities will be receive sensor data, authenticate the data that we have already know, and then store it in MongoDB. And it also serve data to front end. Basically, it directly send data to front end as well. Like if we have backend, it can directly send data to front end, or it will send data to database, and from database it can send to front end. Basically, if we are working on real-time data, then the data will directly come to backend and forward to front end. But if we are showing data that is historical data, means of yesterday, the yesterday's data will be in the database. So if anyone wants historical data, means yesterday's data, then it will directly go to that backend. Backend call the database, and then from database the data will be stored on the front end. So this is what the flow will be, right? So let's see here. So this is how the data will be, how the server code will. This is how we write server data. This is Express. We just require these two things.
You are sharing the screen. Are you going to share something else? Because we can
Oh,
see.
sorry. I see. I think I have disconnected and the time is over. I think something happened like that. Nothing like that? Okay, sorry. I think the meeting has been ended. Okay, so these are the. Should we continue?
Yep.
Okay. So these are the two things we have to require in our server. First is Express because we are creating our app in Express, and second is Mongoose. Mongoose is for MongoDB that we have to connect the server or we have to connect the database that is of MongoDB. So this is for that. So simply we just have to require these two things, and then we have to create our app with the Express. So with the Express, we simply create our app, and then forwardly we will use this app here, right? Uh, okay, I was muted. Sorry. So we will create our app through Express, and then the main thing is this part. But this part, the other things are also important. So for this, we will just use the express.json because the data is in JSON form that will be in our server. So we will use express.json to be used in our app, and let's take it to down, and we have to see the backend means backend logs etc. on our web. So we will use a dot listen. By dot listen, we can simply listen our web on any local host like here we will use any local host like this is 80 that, but we will hear our server on localhost 5000. This is how it will work, right? So where is that? So this is why we use this 5000 listen port. Basically this is port, right? And after it will successfully running, it will give us console.log. Console.log is the log message that will show us that the port is running fine. Okay, so this is the part that help us fetch the data. Basically it will create a dot post function with /API/data path. Like if there is if there is my website, the data will be on /API/ what was that? Mhm. Wait. /API in my code /API/data, right? So that will be /API/data, and at this part we can see the system of our backend where it is running, and it will create two parameters, request and response. REQ is request, RES is response. So simply once we request that them for data, and that they will respond. First, we will request them to give us data, and then it will give us the response in the form of the data or in the form of denial. Here we can also add like try. Wait. We can also add try catch functionality, where we will just try to get data. If we have any error, it will catch error, and then it will give us like in response dot error. And it can also give us any messages, error, getting data, etc. Anything, right? This is how it works. And if we get data, it will just simply give us the message receive data with status code 200. 200 status code means uh, it means it's okay, means data is coming. Data has been received, right? So this is the thing. And let's go forward. So here is our database. We are using database that is MongoDB basically, right? So why we are using MongoDB? Because I already told you it is in the form of like collections that is more similar to JSON file. That's why it helps us. Also, it is schema flexible, good for sensor data. And for schema flexible, we will just create a simple schema. We will also see the code snippet of database as well. So it is good in schema flex, good for sensor data, and it can easily handle large time series data as well, because in the collection it is very easy to getting the flow of the data as well, and it is easy to integrate with a Node.js as we are using Node.js. So for MongoDB, the code is very simple, like now it's good. So here is examples sensor data, and we will just simply create a new MongoDB schema, right? And this is function brackets basically, and in between this data is similar to the JSON. Like if I go to the JSON file that I have told you before, like same structure and device id, and that I told you like it will get the string type of data, it will get number type of number data, it also get number data, and for that it will get date. Basically this is the date, and for time it added t, and this is the time, and this is time zone basically. So this is how it is friendly with MongoDB, and easy easy to see everything very clearly. So we will just add it into sensor schema, and then we will use anywhere sensor schema. We use anywhere this part with the name sensor schema. Right. Oh, sorry for that. Okay, next there is a final stage, that is our front end in React. So the final thing, we have to show our data in the front end. For now we have we have been collected data from means IoT devices. Then we have created our server. Also we have done with databases. Now the final thing is our front end dashboard that we have to create. And in our front end dashboard, the front end, let's see front end dashboard features. It will be real-time data, historical data that I was telling before. Like real-time data is the data that is for right now, and historical like for yesterday and day before that. And for devices status, is devices giving the data accurately, or is there any problem, and also alert, etc. And the common UI components. UI components are the parts that we can use again and again, like if we have different pages, one for the real time and one for historical data, both have same charts and same graphs, but the data in that can be different. So for that, we can use line charts, cards, tables, and for charts, we will use recharts, charts.js. This is the resources from where we can easily do our work. For UI part, we can use Material UI. In Material UI, the components are already created, and we just have to use them uh, easily, repeatedly. And for Node, Tailwind is CSS library. We can write the code in inline HTML as simply. And for API calls, it's for Axios that can help us async and await functionalities as well.
Mr. Azan, since the time
Yes,
is almost over, I think that it would be better if you can come to the conclusion. Is that
yes,
possible?
yes. This is last part.
Yeah.
Okay, for that, we will just use the use effect for fetching our data from the same path that I told. And then we will just use .10 response data, and that will just easily fetch the data and give us. And now for the deployment part, we have to deploy our front end on Vercel or Netlify, on backend on any platform like that. For front end, we mostly use Vercel. Like if we are here, and you can, if you see my web, it is on Vercel.vercel.app. So this is how we can deploy our website also for free. Uh, yes. And here are these some steps that we want to learn. We just have to learn the basic JavaScript fundamentals. Then we have to, for backend, we should learn Node.js and Express MongoDB. These are the basic things. And for CRUD, this is create, read, update, and delete APIs, etc. And all that. I will share these slides that you can easily visualize these things as well. And thank you so much. This is all from my side, and here is from where you can connect with me on my LinkedIn, email, or on my website. Thank you.
Fabrizio, you're muted.
Sorry, thank you. As said, thank you, Dr. Azan, for this speech. I think both the speeches were very interesting from different perspective. One was very, cutting edge research. The other was very practical and helpful for practitioners in the field of IoT. I think that unfortunately we ran out of time, so already by 10 minutes. So I think that we don't have time for questions, but you received some questions in the chat. So it would be nice if you can take this question and send me the answer. I will provide them to those who were attending. I want to, again, thanks the speakers. I want to thank the officers who helped with the organization of this webinar. Let me share just for 1 second this slide for those who weren't maybe are not yet members of the technical talks can of the technical committees can follow this QR code to join. That is our last talk for 2025. The next webinar is already planned in 2026, so you will receive the invitation. Thanks again for joining. Thanks again for contributing, and see you in 2026. Bye-bye.
Okay, bye. Thank you.
My best wishes, of course, for a great end of the year and beginning of 2026 to all of you.
Yeah, thank you. Same to you.
Bye-bye.
Bye. Thank you.
Thank you.